In this video, we're going to be adding and subtracting algebraic expressions, and we're going to start off with addition. All right, when adding algebraic expressions, you're essentially just combining like terms. Now, at the beginning, each expression will be written inside of parentheses, like in this example here. We have the expression negative 9u plus 13, and we're going to add it to the expression negative 5u plus 8. All right, I want to be able to add these two expressions together, but in order to do that, I need to get rid of these parentheses. And the way that I'm going to do that here at the beginning is by using the distributive property. In front of my first set of parentheses, there's an invisible 1 right there. So I can put a 1 in front of that set of parentheses. And in front of the second set of parentheses, I see this plus sign, but that's also a positive 1 that's in front of that set of parentheses. So I'm going to start by distributing 1 to each term in both sets of parentheses. Now, when you distribute a 1, when you multiply by 1, these terms aren't going to change. So instead of having two separate expressions that I'm adding together, I'm just going to have one long expression now when I do the distributive property. So 1 times negative 9u is negative 9u. 1 times 13 is 13. 1 times negative 5u is negative 5u. And 1 times 8 is 8. So we have negative 9u plus 13 minus 5u plus 8. Now that the parentheses are gone, we're going to now use the commutative property so that we can get our similar terms together. So we're going to have negative 9u minus 5u plus 13 plus 8. Okay, remember for standard form that we like to have our variables in front, we like to have our constants at the end. All right, now we'll combine our similar terms. Negative 9u minus 5u, that's negative 14u plus 13 plus 8. And now we can still combine the constants, 13 and 8. So we're going to have negative 14u plus 21 as our expression in simplest form. Okay, so if you're adding two expressions together, remember, in front of each set of parentheses, there's really a negative 1 that you're going to distribute to start. In our next example, we have the expression 1 half x minus 3 minus 2y, and we're going to add it to the expression 1 fourth x minus 2y plus 5. Remember that we have a 1 in front of each set of parentheses here, so we're going to distribute 1 to each term first. All right, but again, multiplying by 1 isn't going to change the signs of the terms. So we're going to have 1 half x minus 3 minus 2y plus 1 fourth x minus 2y plus 5. Now that we've used the distributive property, let's use the commutative property to get our similar terms together. All right, x's go before y's, so we're going to have 1 half x plus 1 fourth x minus 2y minus 2y minus 3 plus 5 for our constants at the end. We have to do 1 half x plus 1 fourth x, but I need a common denominator here. So for halves and fourths, I'm going to use fourths. So 1 half x, that's just going to become 2 fourths x. So I'm going to do 2 fourths x plus 1 fourth x to make 3 fourths x minus 2y minus 2y minus 3 plus 5. Now I'll combine my similar y terms here. Negative 2y minus 2y is negative 4y. So we're going to have 3 fourths x minus 4y minus 3 plus 5. And that leaves me with the constants, negative 3 plus 5, which is positive 2. So we're going to have 3 fourths x minus 4y plus 2 as our simplified algebraic expression. All right, let's go right underneath and look at that example. We have x minus 5 plus x cubed, and we're going to add it to negative x cubed plus 4x squared minus 3x plus 1. Again, we'll start by distributing positive 1 to each set of the parentheses. So we're going to have x minus 5 plus x cubed minus x cubed plus 4x squared minus 3x plus 1. Using the commutative property now, we're going to rearrange our terms. Highest exponent goes first, so we're going to have x cubed minus x cubed plus 4x squared plus x minus 3x minus 5 plus 1. Now we'll combine our similar terms. X cubed minus x cubed is 0, all right? Anything minus itself is 0, so I don't have any x cubes anymore. So that's 0. And there's nothing to combine with 4x squared, so I'm just going to bring that down, 4x squared. And now I have positive x, which is positive 1x minus 3x. All right, well, 1x minus 3x is negative 2x minus 5 plus 1. And now the only thing that we have left to combine is negative 5 plus 1, which is negative 4. So we're going to have 4x squared minus 2x minus 4 as our expression in simplest form. In our next example, we're told that Delilah signs up for a health club and a rock climbing gym, and they want to know what expression represents her total fitness cost after M months. And if I look at the advertisements for the two places, I've got Rudy's Rock Climbers. All right, Delilah's going to pay a $65 initial fee to join the club, and then she's going to pay $40 monthly. So if I were to make an algebraic expression for Rudy's Rock Climbers to represent the total fitness cost after M months, all right, Delilah's going to have to pay $65 to join, and she only has to pay that once. Plus, she's going to have to pay $40 for every month M. Okay, so 65 plus 40M represents the fitness cost of just Rudy's Rock Climbers after M months. If we look at Ace Health Club, Delilah's paying an initial fee of $80, and then every month after that, she's going to pay $50. So if I make an expression for Ace Health Club, all right, initially to join, Delilah pays $80, plus she's going to pay $50 for every month M afterwards. So these are the two different expressions that represent the fitness cost at each place. To get Delilah's total fitness cost, I have to take these and add them together. So I'm going to take Rudy's expression, which is 65 plus 40M, and I'm going to take Ace's expression, which is 80 plus 50M, and to find the total cost, I'm going to add them together. Well, again, in front of each set of parentheses is a positive 1 that I'm going to distribute to start. So that's going to give us the expression 65 plus 40M plus 80 plus 50M. Using the commutative property, variable terms first, 40M plus 50M plus 65 plus 80. And now we'll combine our similar terms. 40M and 50M is 90M. And then if I combine the constants, the initial fees, 65 plus 80, I'm going to end up with 145. So the expression 90M plus 45 represents Delilah's total fitness cost after M months. And it means that for both places combined, initially she had to pay $145 to join, and then she's paying $90 per month for the two places combined. Now that we are comfortable adding algebraic expressions, we're going to look at subtracting algebraic expressions. All right, subtracting algebraic expressions is slightly harder than adding algebraic expressions, although not much harder. Recall that you can subtract any quantity by adding its opposite. And that's going to be crucial for us to remember as we look through these examples. All right, in example number 1, I have the expression 95 hundredths x minus 4 hundredths, and I'm going to subtract from that the expression 99 hundredths x minus 13 hundredths. Okay, again, my expressions are written inside of parentheses here to start. I want to get rid of those parentheses, so I'm going to use my distributive property to start. There's an invisible 1 in front of this first set of parentheses, but instead of the second set of parentheses, there's really a negative 1 right here. So I'm going to distribute negative 1 to each term in the second set of parentheses. This is how the subtraction differs from the addition. Now, since I'm distributing 1 to the first set of parentheses, these two terms aren't going to change. That's going to be 95 hundredths x minus 4 hundredths. Okay, but with the second set, I'm distributing a negative 1. So I'm going to have to do negative 1 times 99 hundredths x minus 1 times negative 13 hundredths. All right, negative 1 and negative 13 hundredths. So I'm still going to have 95 hundredths x minus 4 hundredths. And now if I do negative 1 times 99 hundredths x, that's going to be negative 99 hundredths x. And negative 1 times negative 13 hundredths is positive 13/100. Okay, so the signs of my second two terms have changed since I multiplied by a -1. Now use your commutative property. We'll have 95/100x minus 99/100x minus 4/100 plus 13/100. And now we can combine our similar terms. 95/100x minus 99/100x is going to be negative 4/100x. The signs were different, so I subtracted the absolute values to get the 4/100x, and it's negative since negative 99/100 has the bigger absolute value. Minus 4/100 plus 13/100. Now I can combine my constants here. Negative 4/100 plus 13/100. Again, they're different signs, so I'll subtract the absolute values. And the bigger absolute value is the positive this time. So I'm going to have negative 4/100x plus 13/100 minus 4/100 is 9/100. So our expression in simplest form, negative 4/100x plus 9/100. In our next example, we have 17 plus 4.5m plus 8k. And we're going to subtract 7.5m minus 9 plus 4k. Let's get rid of these parentheses here by using the distributive property. There's a 1 there. There's a -1 in front of the second set of parentheses. So if we distribute 1 to the first set, they're unchanged. 17 plus 4.5m plus 8k. Now let's distribute the -1 to the second set. -1 times 7.5m minus 1 times -9 minus 1 times 4k. All right, so we still have 17 plus 4 5/10 m plus 8k. And now -1 times 7.5m minus 7.5m. -1 times -9 is +9. -1 times 4k minus 4k. Rearrange your terms alphabetically with the variable. K comes first. 8k minus 4k plus 4 5/10 m minus 7 5/10 m plus 17 plus 9 for our constants at the end. Now we'll combine our similar terms. 8k minus 4k is 4k. And then I'm going to move on to my m terms. All right. 4.5m minus 7.5m is -3m. So we have 4k minus 3m plus 17 plus 9. And now when we combine our constants here, 17 plus 9 is 26. So we'll end up with 4k minus 3m plus 26 as our expression in its simplest form. All right, let's try that again. Let's jump down to the bottom of the page here. And I'm going to do this example here. We have 4x minus 3x squared plus 8. And we're going to subtract -6x squared plus x minus 1. We'll start again by distributing 1 and -1 so that we can get rid of those parentheses. Distributing 1 makes this 4x minus 3x squared plus 8. Now we'll distribute the -1. -1 times -6x squared minus 1 times 1x minus 1 times -1. All right. So we're still going to have 4x minus 3x squared plus 8. -1 times -6x squared is +6x squared. -1 times 1x is -1x. And -1 times -1 is +1. Now let's use our commutative property, rearrange the terms. Highest exponent first. -3x squared plus 6x squared plus 4x minus 1x plus 8 plus 1 for our constants at the end. -3x squared plus 6x squared is +3x squared. And now when we look at our x terms, +4x minus 1x is 3x. So we have 3x squared plus 3x plus 8 plus 1. And then for the constants, 8 plus 1 is 9. So 3x squared plus 3x plus 9 is our expression in simplest form. In our next example, they tell us that Lita's family wants to put a tiled border around their swimming pool. All right, and this is what this looks like here. All right, now the tile border is all of this that's going around this smaller rectangle, and this smaller rectangle here is the swimming pool. All right, we want to know what expression represents the total area of the border. So I only want the area of this tile border. Okay, so what we're going to have to do here to get just the border area, we're going to have to start by finding the total area of our shape. So we're going to do the total area, whatever that happens to be. And then we're going to find the area of just the pool that's this rectangle here in the middle. So we're going to do the total area first. Then we're going to do the area of the pool. And if I take the pool out of the total area, that's just going to leave you with the rectangle, or excuse me, the border around the rectangle. So I'm going to do the total area minus the area of the pool, and that will equal the area of the border. Okay, so let's see how we can figure out the areas of the total shape and the pool. Now, both of those are in the shape of a rectangle, and to find the area of the rectangle, remember that you need to do the base times the height. So if I want to figure out the total area, I have to figure out how much is this total base, which goes from this corner to this corner, and how much is the total height, which goes from this corner down to this corner here. All right, well, if we start with the base, okay, I see here the base of the pool is 14 feet. And then we've got the tile over here, which is 2 feet wide. And then we have the tile over here, which is also 2 feet wide. So this is 2 feet, this is 2 feet, and this is 14 feet. 2 plus 14 plus 2 means that the base is 18 feet wide. Now we have to do the similar thing here for the total height. The height of the pool from here to here is 2x plus 14 feet. And then the height of the tile here is 2 feet. The height of the tile here is 2 feet. 2 feet plus 2 feet is 4 feet. Plus this 14 feet is 18 feet plus the 2x. So the total height here is going to be 2x plus 18 feet. All right. So to get the total area of my rectangle, I'm going to do the base, which is 18, times the height, which is 2x plus 18. All right, and this expression represents the total area. Now I'm going to find the area of the pool, and the pool again is in the shape of a rectangle. So again, I need to do the base times the height. Well, the base of the pool from here to here is 14 feet, times the height of the pool from here to here is 2x plus 14 feet. So this represents the area of the pool. To find the area of the border, I'm going to take this area and subtract them. So here's our expression that's going to equal the area of the border. To simplify this expression, well, again, I've got parentheses here. I don't want parentheses. I'm going to distribute first. So I'm distributing 18 to the first set of parentheses. I'm distributing negative 14 to the second set of parentheses. We're going to do 18 times 2x plus 18 times 18 minus 14 times 2x minus 14 times 14. When we multiply 18 by 2x, we get 36x. 18 times 18 is 324. Negative 14 times 2x is negative 28x. And negative 14 times 14 is negative 196. Now we can use our commutative property to get the similar terms together. 36x minus 28x plus 324 minus 196. When we combine our similar terms, 36x minus 28x is 8x, plus 324 minus 196. And then positive 324 minus 196 is positive 128. So we get 8x plus 128. And this expression here represents the area of the tile border. All right, this is the expression that we got after we subtracted the total area and the pool area. So again, that represents the area of the border of the pool.